All right, welcome back everybody to episode 9 in the multi-cloud network architecture series. In this episode, Dana Systems, my company, has grown so fast that we now need to figure out how to automate our deployment model. We need to make this more seamless, more efficient. And so today I've invited an expert at Aviatrix in automation. His name is Abhishek Bhat, and he's done so much for my customers, and I'm really excited to have him here. The requirements are that everything we did in the past needs to now be automated. You know, all the transits, all the site to cloud, all the direct connect, all the FireNet, all that stuff we did needs to be automated now. Number two, this needs to be supported across multiple clouds. And lastly, this is going to help us build automation that will be leveraged to construct a CI/CD pipeline. So Abhishek, I'm going to give you the screen and I'm going to have you run through this for us.
Thanks, Dana, for having me. And I would love to talk about the automation capabilities of Aviatrix. What we want to cover today is Terraform, the Aviatrix Terraform provider, and how it is helping customers build their multi-cloud topologies. So to level set, let's talk about what Terraform is and what it's good for. Terraform by far is the most popular infrastructure as code tool out there. It allows customers to define their infrastructure using a high-level config language that HashiCorp sort of made up. And Terraform uses a declarative syntax where the user describes the infrastructure that they need, and then Terraform generates an execution plan to deploy that infrastructure. As the infrastructure evolves, Terraform is able to determine a delta and actually generate execution plans. Terraform has a concept of infrastructure state, so it always knows the delta between what was intended and what is actually out there. So by running, for instance, a Terraform plan command, you can, at any given point of time, see the delta between what the intended state was and what the actual state is. This is a key capability of Terraform and is used often on an ongoing basis for compliance. The Aviatrix Terraform provider is actually an official Terraform provider, which means it is hosted by HashiCorp on their website, including the documentation. There is a rigorous process to achieve the official status with HashiCorp, and to achieve that, HashiCorp dictates certain coding standards, documentation guidelines, and comprehensive acceptance testing. Those test cases are executed each time Aviatrix updates the provider.
Yeah, Abhishek, that's awesome. A lot of my customers use Terraform today, but Terraform's been around for a while, and so I'm curious, what's the exact benefits of leveraging Terraform along with the Aviatrix networking platform?
That's an excellent question, Dana, and something that comes up very often when we discuss Terraform with our customers. Let me actually show you what Aviatrix Terraform provider offers. So what you see on this slide is horizontally different resources that the Aviatrix Terraform provider can program. And vertically, this slide is broken up by different cloud providers. So really, the capability that the Aviatrix Terraform provider gives you is to seamlessly move between these layers. You can program native constructs, you can program obviously the Aviatrix constructs, and you can move across cloud boundaries using the same Terraform provider. The Terraform provider also exposes resources that are highly abstracted, and we'll talk about those in subsequent slides. And all of this comes together in the prescriptive deployments we have to solve the major networking and security challenges faced by enterprises today.
Okay, so that makes a lot of sense, Abhishek. So if I understand correctly, this allows us to operationalize the automation architecture across multiple clouds with a lot of ease.
That's right, Dana. And what I want to talk about next is a typical deployment lifecycle. Day zero, which is architecture discussions, proof of concepts. Day one, which is building out your production environment, and then leveraging that build automation for an ongoing testing and validation as the network evolves. So let's start with day zero. I know this episode isn't about architecture, but I cannot emphasize enough how important it is to figure out the right architecture for your network before you start to do anything.
Yeah, I totally agree.
And the guidance I would give all my customers is you can start your build automation at day zero. As you iterate over different designs, you can continue to iterate over your build automation as well. And by the end, when you have a final architecture, you also have your build automation ready to now deploy your production network. Day one, I want to get into some advantages. I list out a few here. I mentioned this before. The Aviatrix Terraform provider is multi-tenant and multi-cloud. So even for a customer that is deploying their footprint in a single cloud, we see that most large enterprises deploy their infrastructure across tens, if not hundreds of accounts. The Aviatrix Terraform provider, every resource has an input parameter where you can specify the account in which that resource is deployed in. So the point here being that deploying infrastructure across potentially hundreds of accounts has never been easy. We obviously extend this abstraction of multiple accounts across cloud providers. So you can easily switch between clouds deploying the same resource. Aviatrix resources are also highly abstracted, and there is considerable amount of intelligence in the resources. And we'll talk a bit about these in subsequent slides. And last but not the least, for day one, like I mentioned, the guidance always is start leveraging Terraform early while you may still be iterating over your design. That ensures when your design is ready, your build automation is ready to go as well. And once your build automation is ready, you've deployed your production network, you can continue to use that build automation for things like compliance, audit, and in context of the Aviatrix provider, you can audit policies that are being used. You can audit network routing that the Aviatrix platform orchestrates. And the eventual goal of all build automation is to develop a CI/CD pipeline, which is build, test, deploy. The goal here is being able to spin up infrastructure, run automated tests, and verify any network changes in a test environment before they ever get pushed out to the production network.
Perfect. That's exactly what my customers need, and that's what my fictitious company, Dana Systems, needs. So let's go take a look at how that's done.
So the next thing, Dana, that I want to show is give you examples of the multi-tenancy that I spoke of. Okay. So I mentioned multi-tenancy in terms of multi-accounts within a single cloud provider. Of course, multi-tenancy in terms of being able to deploy the same resource across different cloud providers. And we allow customers an additional layer of multi-tenancy, which is RBAC. Customers can actually deploy RBAC and tie roles to specific cloud accounts.
Yeah, and I did a video on that one recently. So if you guys haven't seen it, go back and watch the RBAC video. It's really popular.
I did see that one day actually, and it was fun.
Awesome.
So here on this slide, this is perhaps a simple example I use often to demonstrate the idea of multi-account and multi-tenancy. And so the resource here is a Aviatrix VPC, which, as you may guess, deploys a VPC based on the input parameters. And what I have highlighted here, two very significant input parameters that are exposed in every resource in the Aviatrix provider. The first one is cloud type, and this essentially allows you to use the same resource and just switch out cloud type, which means if you switch this to the value corresponding to Azure, this same resource would actually go to Azure and deploy a VNet. And the example here uses a cloud type 1, which is associated with AWS. So in this case, this resource would deploy a VPC in AWS.
Okay, I can see how powerful that is. That's fantastic.
Right. So working with multi-cloud hasn't been easier before. And the other aspect here is the account name. On the Aviatrix controller, you can onboard multiple accounts. All our customers typically use multiple accounts for various reasons. Once the account is onboarded on the controller, you can specify for every resource the account that you want to deploy that piece of infrastructure in. And this allows essentially the granularity of deploying each resource in potentially a different account. All right, so then next I want to talk about the abstraction and the intelligence that's built into the Aviatrix platform and exposed via the Terraform provider.
Okay.
So again, going back to the Aviatrix VPC resource in the provider, as you can see, this is a single resource. Mm-hmm. The point I want to highlight here is this resource, when deployed, actually translates to tens of different resources in the native cloud provider language. So what I mean is, when this VPC is deployed, the Aviatrix Terraform provider not only creates the VPC, but it also creates subnets, route tables, mapping of subnets to route tables, private subnets, public subnets, internet gateways, and everything.
Wow.
So that is really powerful. That's what I mean by highly abstracted resources. Lesser code means lesser problems.
Yeah.
The other thing that is significant here is there are multiple guardrails built into these resources. So if you try to deploy resources causing, for instance, overlapping seeders, routing loops, black holes, you will actually get an error back which calls out those errors. And the other important aspect is within these resources, we configure the infrastructure as well as the configuration required of that resource. So what I mean, for instance, is when you deploy the Aviatrix data plane, you can deploy an Aviatrix gateway and never have to worry about, SSHing into the gateway, trying to configure IPsec or BGP. All of that is taken care of by the provider.
Got it. Makes a lot of sense, Abhishek. But what I'm curious about is, when you're deploying infrastructure, you don't do it so often or all the time. And so I'm just curious, what's the benefits of automating this deployment?
That's a great question, Dana. And, again, working with accounts that may not have mature DevOps teams often come up with that question. But build automation is not only for day one. The automation that you build to deploy your production network can be used on an ongoing basis, and you can actually construct a CI/CD pipeline using that build automation. And, just a little background on what CI/CD is. A lot of terms get thrown around like infrastructure as code, CI/CD. What does it actually mean and where did it actually come from? Now, these are practices that really came from the processes, software developers follow when they are developing code, right? And the processes they follow are, fundamentally use of version control. Within that version control, they have a concept of branches, which are sort of isolated copies of code, which can be worked on in parallel. And once that work is done, they have a concept where you essentially now merge those two copies. So those two copies have diverged from each other since changes were made locally.
Got it.
And the process of merging those two branches is significant work. And so over the years, software developers have sort of perfected this art. They've developed practices around, using branching for development, best practices for merging code, best practices around automated testing, how frequently it should be done. And infrastructure as code is really the concept of bringing these practices to infrastructure. In our case, public cloud networking and security infrastructure.
Yeah.
Right. And this is where the build automation that you worked on, day zero, day one, can be leveraged. Across the board, any experienced network engineer you talk to, there are numerous studies out there which explain that a leading cause of outages in networks is human error and unintended consequences of production changes. That's exactly what CI/CD tries to address, right? So the concept is that before any change is made, before you introduce a new feature in your production network, you can build a replica that mimics your production network and essentially run all your testing on that replica, make sure the changes actually make sense, don't cause any unintended consequences. And once everybody is happy, you are now ready to push those changes out to a production network.
Yeah, totally get it now. I love it. Makes so much sense.
And adopting CI/CD practices drastically reduces production outages. The guidance here is, if you are working at a company that does not already have a mature DevOps workflow, my recommendation would be to start small, right? My mantra for automation always is, start small, iterate often. That is usually the safe strategy, so that your entire team is ready to adopt new workflows, new CI/CD workflows. And I think a key step of moving towards CI/CD is adopting version control. The first step towards a CI/CD is adopting version control. You can use open source version control systems. Git is by far the most popular version control system. GitHub obviously is the SaaS version for Git, which is used by many organizations.
Yeah.
Once your code is in a version control system, you can then start to take small steps towards building a complete CI/CD pipeline. At this point, I just want to take a moment to mention some of the advanced capabilities that Terraform has released as part of Terraform Cloud and Terraform Enterprise. Both these versions were released, I believe, in 2019. Most people work with the open source version, which is the CLI version of Terraform. But for a enterprise deployment, you should look at the SaaS version, which is Terraform Cloud, and a self-hosted version, which is Terraform Enterprise. It gives you some advanced features that will help you on your journey of building out a CI/CD pipeline. And Dana, before we get into a demo of an actual build, I wanted to briefly talk about a capability in the Aviatrix controller, which a lot of our customers like. If you are an existing Aviatrix customer who has deployed infrastructure using the Aviatrix controller, but now want to adopt infrastructure as code workflows, you can actually generate Terraform code for all the infrastructure that was deployed using the Aviatrix controller.
Okay, so all the investment I did by hand in my UI is not for nothing, right?
Right. So any brownfield deployments, infrastructure that was deployed using the UI, you can generate Terraform code and start your journey with Terraform.
Cool. All right, this sounds awesome. Really exciting stuff for DevOps and automation in the cloud. But I really want to see it in action. So, Abhishek, show me some demo here.
Yeah. So let's jump to an actual example of a production network. What you see here is a multi-region deployment across 2 AWS regions. The hub right here, the circle right here, is an AWS Transit Gateway. This is actually deployed using the Aviatrix Terraform provider and not the AWS native provider.
Right.
What you also have here is a few dummy VPCs. This is to simulate your workload VPCs, customer VPCs. We also build out a transit VPC using the Aviatrix gateways. This is essentially what allows encrypted inter-region connectivity. And we also build out a dummy direct connect VPC. This is to simulate traffic coming from on premises. It could be a data center or a small branch site. And we simulate this by spinning up a couple of Aviatrix gateways in here as well. What you also see here is a security VPC, which is one of the most popular solutions that Aviatrix offers. This is essentially standing up cloud firewalls and orchestrating traffic in your environment, giving you control over which traffic is being inspected in line by these cloud firewalls. So the structure, high-level structure of the VPC requires two Aviatrix gateways. These act as smart load balancers, and then there are multiple firewalls depending on the requirement of the customer. So we will actually set this entire deployment up using the Aviatrix Terraform provider. A little bit about the Terraform code structure that we'll be using for this deployment. If you don't already have an Aviatrix controller, there's actually a simple module, Terraform module, to deploy the Aviatrix controller. Once the controller is up and running, you can now start to use the Aviatrix provider to deploy out this infrastructure. The way the Terraform modules are organized is the first one is a AWS Transit Gateway. Like I said, there is a resource for the AWS Transit Gateway in the Aviatrix provider. So we use that resource to deploy the Transit Gateway in both regions. We create VPCs using the Create VPCs module. We set up the Transit VPC along with the Aviatrix gateways in them using the Transit Net module. Mm-hmm. We use the TGW FireNet module to stand up the entire VPC and the infrastructure inside it, which means the gateways and the firewalls. And lastly, we use the on-prem module to simulate a data center connecting directly to the Aviatrix edge gateways. The rest of it is a standard Terraform structure. We call these modules from our root module, and there is a Terraform TF-vars file that allows you to specify values for all variables supported in this deployment. All right, so now let's switch to my terminal to see this code in action. So right here, I have the Terraform code that we just covered. You can see a bunch of Terraform modules that we covered, and there are some extra modules that we are not using for this demo. The first thing I do is a Terraform init, and this will show you all the modules that are being used to deploy this infrastructure. You see every module twice because we are building this infrastructure across two regions. The other thing to note is, as of this video, we are using the Aviatrix Terraform provider version 2.13. So let's run a Terraform plan to see what resources will actually be deployed.
Okay.
So as expected, this gives you a view of all the resources that will be deployed to stand up this entire production environment. This creates, like I said, multiple VPCs. We also create test instances on those VPCs.
Oh, great.
So that when your network is up, you can actually test connectivity across the two regions as well. Mm-hmm. Everything in this output looks good. So I think we are ready to pull the trigger and deploy this infrastructure.
Let's do it.
And there, the Terraform apply just completed. In less than an hour, we were able to build the network that we saw earlier from scratch. And now if I jump to the UI, we can see all the resources were correctly deployed. So we can see a bunch of gateways. This is across transit, the FireNet, and you can see here that they are deployed across two regions, in this case, US East 1 and US East 2. We also created a bunch of VPCs to simulate traffic. Mm-hmm. You can see here there are transit VPCs both in East 1 and East 2. There are some workload VPCs to simulate traffic. We also have the firewall VPC. What you can also see here is we also were able to connect those VPCs to the AWS Transit Gateway. You can see the workload VPCs are connected. You can see the transit VPC is connected, and so is the firewall VPC. And last but not the least, if we jump to firewall network setup, we can actually see, in this case, I chose to launch Palo Alto firewalls. So you can see the VM series are actually spun up and ready to go. So the next thing for the firewalls is to go ahead and configure security policies.
Yeah, so it also configured all the routing for us end to end, and every instance, every VPC, every attachment, every gateway, it's all done for us, right? No, we didn't have to do a single thing with routing here.
That is right. So all the routing, transit routing between the regions is all set up. We can actually go in the UI and click on details, and it'll show you all the routes that it's already learning across regions.
Got it. How awesome is that? Abhishek, that was awesome. Thank you so much for showing us that. Really, it's amazing how all the work I did in my previous MCNA series videos, like building the global transit layer, doing the high performance encryption, doing the on-prem connectivity, the SD-WAN, the segmentation, all of that could be operationalized and made more efficient using Terraform automation. So for all those who are watching my MCNA series previous videos, we were working in the cloud operations layer of the MCNA. Next, I just really want you, Abhishek, to summarize what exactly did Aviatrix do for us today?
Yeah, sure, Dana. So what we demonstrated in that deployment are key capabilities of the Aviatrix provider. We had the flexibility to deploy that infrastructure across multiple accounts. For example, typically enterprises deploy their security and network infrastructure in dedicated accounts. The example we saw was a transit FireNet deployment across 2 AWS regions, but you could deploy the exact same infrastructure with minimal changes actually across 2 completely different clouds. We also benefited from all the embedded intelligence in the Aviatrix platform. This prevents a lot of common pitfalls, like I mentioned, inadvertently creating black hole routes, duplicate addresses, routing loops. So we benefit from all that embedded intelligence in the platform. And last but not the least, it sets you on your path to actually building a CI/CD pipeline, the benefits of which can be realized over a long period of time.
Truly amazing. Thank you so much, Abhishek, for joining me today. I really appreciate your time. I know it's valuable, and I think that this was super valuable. Everybody who has been following my series has been asking me about the automation piece of Aviatrix, and you really covered it well. So thank you so much.
Thanks for having me, Dana.
All right. Take care.
You too. Bye.